Good morning to all of you. In context of first lecture of electronics, today I want to discuss about the energy band, how energy band form, and what is its significance in context of electronics and its usefulness. It is very clear, as per the Bohr model of atom, we understand if we consider single atom, then atom have different energy levels, and when we consider the collection of atoms, that is in context of semiconductor crystal, all of you know in the 1 cubic centimeter volume have 10 to the power approx 22 atoms. So when number of atoms increased in comparison to 1, then energy levels presented in the multiple number. It's very obvious that if for one atom have one or more than one energy level, then 20 atom must have at least 20 or more than that energy level. So as for the discussed volume, number of electron is 10 to the power 22. So for the given crystal, semiconductor crystal, all atoms are collected in a group. So energy lines will become energy band. And this lines is form energy band, and this energy band is finally divided into two parts corresponding to the valence band and conduction band. And on the basis of these bands, we classify the matter as a conductor, semiconductor, and insulator. And this gap of energy is very clearly shown here, and explained here. For the given single atom, if we consider valence band and conduction band, then it is shown here in figure 1. But when we consider if 5 atoms are collected in a group, then it forms a band. Lines behaves as a band because lines are overlap on each other. And lines are collected. So, as for the one atom, one lines in comparison to the conduction line, and one line is for the valence line. Similarly here, corresponding band is called valence band, and corresponding to this is called conduction band. And the difference between them is called energy gap. Conduction band is the band where electrons can freely move and feel free to move, whereas in the valence band they are not feel such environment. In this given diagram, if we consider the energy lines of the given atom, then it is divided into different regions, that is on the basis of interatomic distance. Suppose one atom is here and other atom is here, then distance between them is more. But when two atoms are come near about each other, that is this interatomic distance will more, that is from 0 to this point, that is at the point of D, then the number of lines are very less, and there is no chances of splitting. When distances, interatomic distance will become less, the number of lines is increased, that is splitted, and this splitting of electronic lines is explained on the basis of Pauli exclusion principle and other quantum mechanical laws. That is, energy lines splitted here. One line becomes 2. Here other line becomes 2. So finally, splitting also important to understand the band, either conduction or valence. Similarly, the electronic structure for the sodium, that is electronic configuration of the sodium, is taken under consideration, then energy lines are shown in this diagram. Splitting is shown for more than one atom, and number of lines will also multiply, and finally energy band for the sodium crystal will come in front of you. And on the basis of band structure, matter is divided as conductor, insulator, and semiconductor. Then main parameter is energy gap between conduction band and valence band. So if it is greater than 3 electron volt, then it is insulator. Less than 3 electron volt, then it will come in the range of semiconductor. And when energy gap have value less than 1 electron volt, then it will come in the range of conduction band, conductor. That is, this distance will become very less. That is, we can say the bands are overlap on each other, this distance will become very less, maybe 0, maybe 0.5 electron volt, etc. But in this diagram, we represent the difference in conduction band and valence band for the given atom of semiconductor. Now we discuss Fermi energy level. Fermi energy level is defined as the energy level in the intermolecular distance energy graph, and normally it exists in between conduction band and valence band, and it may be in the upper part of the valence band. And in this way, Fermi energy level is the level where the probability of finding is more at 0 Kelvin temperature. Probability of finding of electrons are more. And in this way, on the basis of Fermi level, the semiconductor, metal and insulator are explained here. In this case, it is in the middle part. In this case, it is near or in the conduction band. In this case, it is near the valence band. And finally, I want to summarize the total essence of this lecture is formation of energy band of the semiconductor crystal because if we understand the energy band theory, this is the effect of energy lines of atom and group of atoms for the given crystal, then we understand where electron can flow. And when more electrons are collected, then electrons interact with the electrons of other atom, and on the basis of this interaction, energy lines split it. And under the effect of splitting, under the effect of interaction, and due to the collection of large number of atoms in the group, the semiconductor, for the given semiconductor, band will form. And after the formation of band, we understand where electron can move and what is the importance of valence band and what is the importance of Fermi energy level, what is the probability of finding the electron in the Fermi level. And if you understand what is atom and if you understand where electron can flow, then again in the next lecture we will discuss about the uses of this energy band and hole formation. Thank you.